Today we begin Indirect Proofs. Today you will be able to write indirect proofs, both algebraic and geometric. Although on the geometric, we'll look at it. Okay, but you may not have to do as much. But my main emphasis is going to be algebraic. So, what is an indirect proof? Let's talk about some things first. Let's talk about indirect reasoning. What does it mean to be indirect, besides being, just your average person? Indirect reasoning means that you're using reasoning where you assume like the conclusion is false, and then you try to prove the contradiction. Okay, so you presume that the conclusion is false, and then try to show that showing that the contradiction can be true or whatever. So your focus is on the contradiction. Okay, indirect proof or proof by contradiction assumes that what you try to prove is false. Show this assumption is not logically possible. That means you make an assumption that what they're trying to prove is false, and then you show that assumption cannot be possible. So then you go back to the original conclusion. So if you show that the opposite is not possible, then what was originally asked to be proven is true. I know, it sounds weird, but let's look at it. First up, let's make sure you understand how you can find the assumption to start an indirect proof. Okay, so what are we looking at? What are we trying? What's being proven, and what are we saying it's the opposite of? Okay, so look, here's an example. If 6 is a factor of n, then 2 is a factor of n. Okay, so what that is saying is that we're making a conclusion that 2 is going to be a factor of n. Okay, so we're focusing on that. We want to assume the opposite, or the negation. Keep in mind negation. So we want the not q. Remember how we would say p then q? We want the not q. So in this case, the not q would be that 2 is not a factor of n. Okay, here's another example. Angle 3, that's an angle, is an obtuse angle. So then our negation would be angle 3 is not an obtuse angle. In other words, and so you're going to try to show that those are true. And the reality is that by showing those are not true, that they end up being false, then you would show that your other thing is true. I know, it's kind of weird. It's an indirect proof. All right, so here's one for you. Here's an algebraic indirect proof. Okay, you're going to tell me that you want, given negative 3x plus 4 is greater than 16, prove that x is less than negative 4. So in an indirect proof, you look at this x equals or less than negative 4, and you do the opposite. The opposite of that would be greater than or equal to. Because keep in mind, it's not just greater, it also could be equal. Anything that would be not less than. Okay? So that means I'm saying x can be either negative 4 or greater than negative 4. If that is the case, then what I'm saying is this. If I choose a number like negative 4 or something greater than negative 4, I should get an answer that would be greater than 16. So this one doesn't do your normal, this is more like an informal proof than it is a regular one, like the two-column proofs. So what I did here was I went ahead and said, hey, let me try negative 4 and 0. Both those numbers are, well, that one fits, the negative 4 fits this one, and the 0 fits this one, because 0 is greater than negative 4. If I plug those into the equation, okay, then I should get an answer that would be greater than 16. Well, what happens is when I put those in, I get one that equals 16, not greater, and another one that is way less than 16. So those are both false. Since both of those possibilities were false, that means this right here is false. That means then what I wanted to prove was true, because this proved the contradiction. So, since x greater than or equal to negative 4 is false, then that means, or thus, the x less than negative 4 has to be true. So that proves the thing. I know. Like I said, it's weird. All right, let's look at another one. Okay, so here we're saying if negative c is positive, then c is negative. Okay, focus. So, we want to prove that c is not negative. Oh yeah, I forgot the then. Anyways, So what does that mean when to be not negative? It means that it could be either positive or it could be 0. Because remember, 0 is not negative or positive. Ooh, you got it wise. All right, so what happens here? On this one, I'm going to make a little table. Okay, so if C is 0, negative C is 0. If C is 1, negative C is negative 1. If C is 2, negative C is negative 2. If C is 3, you get the idea. Let's go the other way. Let's say if C was negative 1, then negative C is positive. Okay, so right there, no matter what, when C is positive, negative C is positive, we have two things here that show us that that C is not I should be focusing on the not negative part. Okay, so because that's not true, because we got to do the whole thing, so C is not negative is false because it ends up being that it is negative in all cases. Because remember, we're trying to do this in a general case, so all we had to do is prove one part of this was false. Thus, C is negative when, because this was more of an and. So C is negative when negative C is positive. So there you go. And there's that bell. Anyways, so you kind of get the idea. Now, we'll look and do a little bit more when we do the geometry part of this. So I might do a part 2. But anyway, that's it for today, kiddos. Thank you so much, and y'all take care.